Okay, so Donnie, did you want to just introduce yourself, just so they know who you are?
Well, good morning. I'm Don Hecker, and I'm the flight hardware project manager. And I'm brand new to HUNCH, and I'm really anticipating some really fun times here. It's pretty cool program. A lot of excitement for y'all.
Well, this class is new too, so we want to welcome both of you, the new class, and Donnie to this program. I was just telling them a little bit about how we went from training hardware to flight hardware, and this is all going to be about. I already told them, Donnie, it's all about math, and I was a math teacher. So the quality assurance is right up my line. I wish I knew manufacturing more, but I really don't. So, okay. And I did talk to Gene Gordon, and he said he introduced you to the program. So, Mr. Hall, I want to know how much time I have.
The students have to leave about, they're usually walking out the door about 10:40.
10:40, did you
Right.
say?
Yeah.
Okay, so that's 8:40 my time. Okay, so if I have time in the end, I'll show you a video, but for right now, I think we'll get right down to getting trained. And I love when you ask questions. That shows you're interested, so just jump in there. I probably will have a hard time hearing you. Somebody by the computer will have to say that question again for me. But I love questions. And the best part is you can take notes. So I encourage notes, and you can use your notes on the exam that we're going to have at the end of this period. So take good notes. I will actually tell you the answers to every question on the test. All you have to do is write it down and use it. And the reason for that is I want you to learn it, right? And I think if you write things down, you can remember it better. And you can always keep your notes. Is that okay, Mr. Hall?
That's great. They're already have note-taking sheets, and it's part of documentation, right?
Okay, so do the students have, can they see a big screen? So when I share my screen, they can see what's on the screen? Okay, good. And do they have a copy of the drawing?
They do.
Okay, awesome. All right, so we're gonna start. I'm gonna share my screen. And I'm gonna share the sound in case I get to. And we're going to start, share my screen. All right, do you see my screen?
Yes, we do.
Okay, good. Oops. All right, first I want to show you a little bit about do you see the handrail?
Yes.
And the part you're making is right here. Is that right? You're making the tube fixture? Okay.
Yeah.
And you see how beautiful it is in a nice anodized, I believe, blue color? Because the astronauts are going to they actually hang on to part of that. Part of it slips into this tube, but this part is out of it. And it has to be like fine jewelry. It has to be smooth as silk, and it's a beautiful part. The handrails are beautiful. And if you look at the space station, there's handrails of all different lengths all over the space station. And sometimes the astronauts grab it with their hands, but sometimes they put their feet under it to hold them down to the ground in place. And if we have time, I'll show you a video with that. But this is the tube fixture. I actually have it right here also. Whoops. Here it is. And this is this part right here is the part that is actually showing, and this part here actually goes inside the tube. And then you have another part that fits into it, and this is why everything has to line up perfectly. So this is called the fixture cap, this right here, and that goes right in there. And everything has to line up. This is a precision made part for the astronauts. We can't have any loose, shaky parts to it. But I wanted to show you all the parts to the handrail, and yours is an extremely important part there. Anyone have any questions about that? Okay, so now I'm going to pull up the drawing. Let's see if I can find it and all my stuff here. Here it is. Do you see the drawing? Okay. And you have that drawing in front of you. So the first thing I want you to look at is down here, and I'm going to make this drawing bigger. One more. And go to the title block, which is right here. And this has some really important information that you need to copy and put onto some of the quality assurance documentation. But you need to make sure you're working with the right part. It's called the tube fixture for the handrail. And to double check, we put a drawing number for all our parts. It has this number down here, and all these numbers for all the parts that I have seen are pretty long like this, and they usually start with 3 letters. And we have here SDG 33117292. That is the drawing number that becomes on when you actually are making a baggie for it with labels that has that number. It's a very important identification number because every single little part you saw on that draw in the handrail has one of these numbers besides being a title for it. The other important part is right next to this number, and it says REV. REV, NASA loves abbreviations and acronyms. REV, anyone know what that stands for? Just, yeah, it's revision. And this has NC, which is no change, I believe. So the revision is no change. They did not change it. But here above, right here, can you all see my cursor when it's going around like that? Okay. Above the word material, and you have it on your drawing, and we're doing we never do the wharf. We always do the plain thing that says tube fixture. So we're doing the -001. Above the word material specifies the type of aluminum alloy we are using. And there's all different types of aluminum alloy. We're using the 6061-T6 aluminum alloy. Under it is a number, and that is measurements for a rectangular bar to purchase, but we don't go by this number. We go by what the teacher thinks is appropriate for their machines to build this tube fixture. So the only important part above material is that 6061-T6. We have to have that on our documentations, where I will show you in a minute. And then the other thing is the specification right next to it, the word specification, the AMSQQ-A 200-8. That specification also has to be on our documents that we include with our parts. And that specification and the material will be listed on what we call the certificate of conformance, which I will I actually think I might show you now if I can find it, which I know I have. Wait a minute, let's look here if it's here. No, it isn't there. That's your file. But I will show you the certificate of conformance shortly. Oh, here's a nice picture. These are the finished handrails. We sent already 11 up to the astronauts, and they want more. So you are working on sending more handrails to the astronauts. Okay, let's go back here because I can't quite find the notes are very important also on the drawing, and the notes are usually found in the bottom. Note 7 says anodized per NASA. Guess what? You do not anodize it. We will anodize it. Actually, we send it out to a shop to get anodized because that involves a lot of chemical process. It's a big process to anodize. But in order to get a beautiful anodized, that part has to be like precision made and as smooth as silk, as finished as much as possible. And so note 6 says, do not break edges indicated. And that actually, I have never seen on any drawing except for this one, because we always want to break our edges. But on this drawing, we don't want to break our edges. And I can show you, actually, I'm going to stop sharing because that's an important part. So here's your fixture cap. The one part where we don't, everything is, I don't know if you can tell, but everything is nicely rounded, no sharp edges, except one spot. And that's right here, that this part of your tube fixture has to be sharp because this fits into it, and it has to be like one. You don't want a round edge there. Does that make sense? So you got to be really careful because always we want round edges, just not on this top right here, because this has to fit into it, and it just has to be continuous. So those notes on the drawing are really important. You need to pay close attention to all those notes. The other thing that I don't see on this, but on the test, is what does DIA stand for? And there's no DIA on this drawing. Instead, there's a circle with a slash through it. But my geometry students know what DIA stands for, right? What is that?
Diameter.
Diameter, right. What does R stand for? There's a lot of R's.
Radius.
Right. Good job. When you all talk, I can really hear you. All right. So I don't ask about the R on the test, but I do say what is DIA. But you guys have this circle with a slash through it. Another very important part whenever you're doing any of the quality assurance work is the drawing takes precedent over any of these forms that I'm going to show you. And there's just 2 forms we're going to go over. But if the drawing says, hey, it's plus 0.005 of an inch and mine is 0 of an inch, that takes precedent of whatever the quality assurance paper says. So when you're doing your quality assurance papers, you need to have your drawing right in front of you, because the tolerances in this drawing are the most important. There could be a mistake in the quality assurance paper, I have not had another person make a fixture tube. So you're one of the few who are making a fixture tube, and there definitely could be mistakes because not a lot of people have made this that I know of, at least. And the 4x means 4 times. 4x, the full radius. And you have special gauges to measure radiuses and diameters. And the only other thing I want to make sure you understand is how these how the drawings are like, I like to say the Cartesian plane in geometry, because the Cartesian plane is the XY axis, and here the X axis, which is horizontal, goes across the top with numbers, and the Y axis goes vertical, and it has letters for our and that's how you indicate where your measurements are. So if I wanted a measurement in this area, that's C, it would be right in here, and it would be C8, right? Because 8 is right. Can't see C when I go to 8, but it's right in here. And we'll look at that again. I actually made this probably a little too big. So maybe now we can see it. It's probably in, this is in C8. This is in C7. But do you all know how to read that?
Yeah.
It used to be on maps, but you Google Map things now, but it's also in mathematics. All right. So now we're going to start on the documents for this. And do you see the document now that says sub-assembly process sheet? And do you have a copy of it? So you can write on this, and I'm going to give you the first one of the questions on the test. There's only 14 questions on the test. The one question says that these quality assurance documents are legal documents, and any legal document, you should not use pencil. You have to use black or blue ink. So write that down if you can't remember it. It's a question on the test. Use only black or blue ink. We don't want pencil, and we don't want orange or purple. This is a legal document you're filling out. And so it should be in black or blue ink. You can use pencil now on your form. You can, this is just for you to learn with. And look
Flo,
here. Yeah.
I'll throw in there right now that since we're talking about it, no Sharpies either.
Oh, absolutely.
Even though it's black ink, but the Sharpie bleeds through and it creates issues.
You bet. And please join me anytime. That's
Okay.
important.
I'm trying to not to bug you.
No, bug in anytime. So just black or blue ink, no Sharpies, no pencil. And you see, you make sure you're filling out the right form, and Jean may give you this form. Unless I sent it to you. I think I already sent it to you, Mr. Hall, did I?
Yes, you did.
Yeah.
Yep.
Okay. So there's the name of the part, and there's the SDG. That's the drawing number that was on the drawing, and the revision NC. That's all filled out for you. The only thing you have to do is put the date. Oh, wait a minute, it's not 10 anymore. It's 11. And I like actually that you put and you put it in this order, but the important thing is that you have the month, day, and the year. And that's a question on the test. Do you have to include the year? And I put out the whole year 2022 just to make sure, because it could be the 22 could be a day of the month. So it's real important. I've watched quality assurance people check our papers, and if we didn't have the year on them, she had to go back and we had to put in all the years. So put in the month, day, and the year. That's real important. I'm gonna highlight it too. So that was the second question on the test. First one, black or blue ink, no Sharpies. This one is you have to include the year when you put the date. And that's all you fill in on this square. Everything else really is filled in for you. But you have to remember to put the date. We don't have a red line number. We just put the date. All right. The third question on the test is you only fill out the top 5 steps in this form. 1, 2, 3, 4, 5. Because if you look, the 6th step is about anodizing, and you don't anodize it. NASA anodizes it. NASA will fill out these other steps, and there's 10 steps, but only you fill out the first 5. And I've had kids get that question wrong. So write it down or indicate it somehow that you're only doing the first 5 steps. You don't do anodize it. NASA will do that and finish off the whole process. Okay. So step 1 is easy. It record the revision, and we already know that it's NC, which I believe is no change. You put that in there, you date it. NASA likes 2 people on all their quality assurance work. So one person will be the technician who's making the part. So they'll put their initials down. And the other person is going to be our quality assurance person. And I think Jean brought you some stamps. Is that right, Mr. Hall?
We'll be getting them coming pretty soon.
Okay, I know he picks them up at Johnson Space Center because I was all out. So these stamps are like your signature. And the question on the test is, can you share your stamps? No, you don't share your signature. You don't share the stamps. You put the stamp in a secure location, and only you can use it. And your teacher will give Jean the name of the student who's assigned this quality assurance stamp. So this form, which is called the subassembly process sheet, or I like to call it, I don't know if you can read this, but it says JSC Form 881 down at the bottom there. So I like to call it Form 881. And you have to have a QC stamp. So there's 2 stamps, a QC stamp that just says QC and then has a number, and an LM, which stands for linear measurement, and it has a number. But only the QC stamp can stamp, the person who has the QC stamp can stamp this form. The LM stands for linear measurement, and that's for this other form we're going to see. The QC stamp can stamp this form or the other one. So the QC stamp is the more kind of powerful stamp, you could say. But only the QC stamp can stamp that. So the person, I don't know what your number is, but we'll put 102. And you stamp that. You put that stamp in a secure location. Don't share it. And if you lose it, you think you're in big trouble, but you're not. Just let your teacher know, and he will tell Jean, and we'll take your name off that stamp and we'll give you another one. So don't stress out over it, but keep it in a secure location, because somebody finds it, that's like your signature. All right. Any questions on step one?
I have a question, Paul, again, about, I have two students with the same initial. Should we differentiate?
Oh, yeah, maybe use the middle name,
Okay,
but in reality, the person who's responsible for this is the person with the QC stamp. That's the final, when you stamp this, you're saying it is correct, it's good. And we would trace it, because most times we can't read initials anyways. But we will have on record, and I have the list from many years now of kids who have been, have those stamps. But yeah, use like the 3 initials if they have. That was a good question. I've never had that question. Okay, number 2, students, it was so confusing for everyone that we wanted information about the raw material, not the description of the part, that I filled this in for everyone. And just what we went over on the drawing, that the raw material must be the 6061 T6 aluminum alloy. The certificate of conformance that comes with it must say that the part number is the 6061 T6. You didn't have to write it in the description. It could have just been aluminum alloy, but I write all of it. And the specifications was on that drawing also. Now I want you to look on the drawing and see if you can find the lot number. And the lot number for this piece is 246383334. So look to see if you can find the lot number. I see one head up. Did you see it?
I'm not finding it. I don't think anybody's found it yet.
No, it isn't on there. And that's a question on the test. Where is the lot number found? And the question actually on the test says, is everything asked in step 2 found on the drawing? Well, the description is the part number, the specification, but the lot number is not. It is found on the certificate of conformance, which accompanies the part. Mr. Hall, did you print out a certificate of conformance for the kids?
Let me take a look real quick.
I'm looking to see if I printed it out here. Hold on.
Okay.
I know I had it this morning. What is this? Huh.
All I got was the only other paper we had, the dimensional inspection for.
Yeah, okay. Well, I actually have a copy right here. Maybe I'll just show you a copy so you get to see it. It's usually kind of big. I know I had it on the computer this morning. Let me stop sharing. Hold on. Okay, so this looks like the certificate of conformance. And you see this part that's circled in here? That says lot number, you can't read it, but that's on this, it says, this one says it's the certified inspection report. Every material must come with something like this that has the lot number, because that tells us exactly what the material is made of. Aluminum alloy has a lot. You think you're just doing math, but you're also doing chemistry, because you can't read the certificate very well, but it has all these different elements that's in that aluminum alloy. But this is also a very important part because, and has to stay with your part you're making because it has the lot number, which tells us exactly how that material was made. And if something goes wrong, we'll say, hey, maybe something was wrong with that lot number. Okay, I'm gonna start sharing again.
Oh, yeah, we do have the material.
Yeah,
We do have that.
it comes with your material. That's why I use this one supplier in New Jersey, because he knows that when I order material from him, it has to have this description, aluminum alloy, it has to have this part number and specification, and it must also have a lot number. And if it doesn't, it's not, I can't make flight material out of it. I can't make flight parts out of it. I have to have all that information. And then all I do is whoops. Got to get rid of that. All I do is put the date, and somebody else besides the quality control person initial it, and it doesn't have to be the same person every time. And then only one person will have the quality control QC stamp. But just remember, because when you are a machinist in an aerospace company or a medical company, they're not going to fill this in for you. But I did, just because so many times it was confusing. We're just talking about the raw material here, not the part. Any questions on step 2? Step 3, machine part per drawing. Just make sure, double check 2 people you're machining the part, and date it, initial it, and stamp it. So that's pretty easy. Step 4 is hard. And the reason is what we've been talking about, that your part has to be so well precision machine and no sharp edges, except on this one case. You do have a sharp edge right here, but all the rest has to be as smooth as silk. And I'm not a machinist, but I believe if you take your time and make this as using the correct speeds and feeds, what they call, and not be in a rush, you will come out with a really nice product, and it will take a lot less to get rid of all the burrs and just keep it as smooth as possible. But there's also a lot of what we call control process that is involved. And that's real important, because we can't have any scratches. So when you're working with your material, even your raw material, make sure it's on a clean surface. Even if you have to clamp something, make sure the part doesn't get marked up. No Sharpies at all on this part. You do not mark your material or anything with any marks whatsoever, but Sharpies seems to be the thing that some people do put on their parts, but no Sharpies at all. Your hands even need to be cleaned. Your surface area needs to be clean. No dragging the material across a surface. So the cleaner you keep this, the better and the least work you'll have to do to get rid of any scratches or anything. It takes a lot of finesse because you can't change tolerances, but you have to round the corners and get rid of the sharp edges. Any questions about that? That takes a lot of patience. All right, well, if you need any special help with that, we have, I think we're going to make a video about it, because if it doesn't have, if it isn't as clean as we need it, then the people that Donnie's working with, they're gonna have to polish it up, and that takes a lot of time. So we appreciate when the students do it. But it is time consuming. And
And you're right, Flo. It's very much of a finesse
it
activity.
is, yeah. It's like
You can
making
have a
jewelry.
beautiful part come off of your machine, very good, tolerance wise, and look wonderful. And you can hack it all up when you're rounding the corners, and that happens at every level of machining. So the better you get that early on, the better of a machinist you'll be.
So would you say if they control their speeds and feeds, that helps with it?
Yeah, it does. The better it comes off the machine, the easier it is to do a little final finesse on it.
Yeah,
Because if you have a really big, burr hanging off that your tool was dull or something, then you pretty much have to use some kind of a file or something to clean it. But if your tool's sharp and you have just a, like you're saying on this one part, it's calling for a sharp corner. An actual sharp corner per one of our drawings that documents all of that. It's called the SKZ drawing. A sharp corner is up to 3/1000 radius.
wow.
So it's not able to cut you, but it is a very sharp edge, basically. Generally, when they're not called out at all, when there's no call out for a break edge, it's 5 to 20, 5/1000 to 20/1000 radius.
Yeah,
And that's pretty much across the board for flight material. And that's, again, it's just protecting the astronauts and keeping the hardware in good shape.
right. And that's really important in this part because it's the handrail where they're going to grab
Correct.
their hands. So that's really important. So take your time. We don't want to pressure you into building this real quickly. We'd rather have it precision made and as beautiful as possible.
Absolutely.
Thank you. Thank you, Tani. Okay. And the last thing is to another inspection sheet. And here it's called 829. And that's the linear measurement inspection sheet, which we will do right now. And I'm just going to date it, initial it, and stamp it. And when you stamp something, it means you're good to go. That's giving it its approval. You stop there, NASA will anodize, NASA will do these next 5 steps. So you only do the first 5 steps. Any questions on this sub-assembly process sheet or 881? Okay.
Right.
So I'm going to pull up the next sheet, which is the linear, it's called Dimensional Inspection Report. It's the linear measurements. And this is all about tolerances and measurements. And you all know how to use a caliper, is that right? Because reading a caliper and telling its tolerances is one of the first questions on the test, but I'm not going to teach you how to read a caliper. So again, I want you to check that this is the tube fixture and it has the right number. And this even put the 001 in there, which is the right number. The only thing you're going to put on this is and for some reason, this form never lets me write on it, but put the date. And the important thing is the month, day, and year. The year is the thing that people leave out, but you have to do the year. You cannot do this in pencil or Sharpie or orange or purple ink. This is another legal form, and it's black or blue ink. And this page here is only for 6 parts. So 6 tube fixtures, and you would label your tube fixtures 1, 2, 3, 4, 5, 6. That's the measurements that all are for part 1, 2 fixture, part 2, part 3, 4, 5, and 6. We'll go over each of these columns now. The print zone, that's where we were looking at the C8, the X and Y axis, I like to call them. But let's see if I can pull up the drawing again. And you guys all have that drawing in front of you. Okay, so the first one was C8. So let's see if we can, oh, there. So C8, here it is, the 4x full radiuses. Now, the question becomes, how in the world do you put 4 measurements in that one little space? 4, so it's asking for 4 full radius measurements. Do you think you could put 4 measurements in here?
No.
I think I heard someone say no. Well, what I want you to do is measure it 4 times, right? And if all of them are in tolerance, then put one, you can put 1 or 2 in there, put the ones that are in tolerance in there. If one of those 4 measurements are not in tolerance, then I want you to put the one that's not in tolerance in there. Because if one of those 4 measurements are not in tolerance, we're going to highlight that and we're not going to stamp that row. Because anything that's not in tolerance is not good. So even if one of those isn't in tolerance, that piece isn't perfect. And we don't want to stamp it saying that it is perfect. Does that make sense?
Yeah.
But if you can put the 4 measurements, put the 4 measurements in there.
So would it be okay to measure them all and then give the lowest reading and the highest reading? So you have a low limit and a high limit, and if the low limit and high limit of the readings are incorrect, then it's good to go, right?
That would be perfect. That's a very good. That's a logical way to do it. As long as they're in tolerance, put the lower and the higher. That would be really good. And this form, so you would do six different parts. And if all of them are in tolerance, there's a question on the test. If all of their measurements are in tolerance, you stamp it. And you can use the QC stamp or the LM stamp. So there's 2 stamps that you will be given. The LM can only go on this form. The QC can go on this form and the other one. But the LM is your signature, just like the QC, and has to be put in a secure location. And when you stamp this column, it means everything is in tolerance in that row. Do not stamp it if one of these is not in tolerance. So if there's one that's highlighted in yellow, don't stamp it, because stamping it says it's a go, it's good. This print dimension has some tolerances on it that were just copied from the drawing. So keep your drawing right in front of you, because these could have been copied incorrectly. We just had interns make these forms with these tolerances, and they could be incorrect. Your drawing takes precedent over it. But I know this is what we looked at that part before, which was 5/1000ths of an inch. It could be a little bigger, but it couldn't be smaller. And that's because we want that actually, it's called the fixture cap, to fit perfectly into the fixture tube. On the bottom of this form, we have some tolerances, but they don't take precedent over the drawings. So if it's different tolerance that's on the drawing, then you do the tolerance for the drawing. And everything, by the way, is in inches. NASA only uses inches. So this is a 100,000ths of an inch, 20,000ths of an inch, and it's plus or minus. And this is 5,000ths of an inch, very little, plus or minus. But a lot of these have other tolerances written right into the drawing, and that was just copied. And there's a DIA on the thing, that's a diameter. All right. Now when you're measuring like 5,000ths of an inch, you need to make sure your caliper is well calibrated. And that's what this column is for, to put down what tool you use to calibrate your measurement devices. So if you're using a caliper, usually it's a 1, 2, 3 block, but we need you to keep your measuring devices in really good shape. And by the way, I meant to, when your teacher was mentioning about the tools not being sharp, if your tools aren't sharp enough, if they're wearing, you need to tell us, and we will get you new tools, because we don't want it's a real detriment to work with tools that aren't sharp enough. You might be doing everything perfectly, but the tool isn't as good as it can be. So we purchased the toolings for you, Mr. Hall. So if you need any toolings, you just tell Jean. Does that make sense? We don't want you to lose measurements because your tools are no good.
Yeah, sounds great.
Yeah, and we have a request form that you can fill out on that. And I've seen it happen. The kids are making parts and the tool wears out, and really then their tolerances are off. So we need to make sure you keep really good calipers and tools to make these parts. So here, if it's all 1, 2, 3 blocks, you would just put a 1, 2, 3 block, and you can put a line down there. But there are 3 pages of measurements. That's a lot of measurements for this part. That's going to take a lot of time to fill out those. This is just page 1. And stamp every row if everything is in tolerance. Any questions about that? So I know you might want to do this in pencil because you could erase your measurements, but 2 pairs of eyes on this also. The way to do it is one person measure the part and one person write it down, and then switch. The person measuring could write it down, and the person writing it down could then do some measurements. But we need 2 pairs of eyes. One person with the QC or LM stamp will stamp it. All right.
Everybody good?
Everybody good with this form? All right. So I actually want to show you one other thing that, let's see if I can find it. Maybe it's in here. Yes, it is. All right. Do you see this space flight hardware manufacturing quality assurance and inspection form? Do you guys see that? Okay. You probably don't have this one. I see somebody. But this is what we send to you after we inspect your parts. So you send, when I tell my teams to make 6 parts. One of those, put 6 parts, put each part in a baggie and put your label. So I sent you labels, put your label on it, and your label will have a number that will correspond to 1, 2, 3, 4, 5, 6 parts. So this is part 1 on that form. Don't put the label on the part. Put the label on the baggie. Don't put anything on the part. Do not mark the part at all, and keep it as clean as possible. So I tell my teams, and I don't know what Jean's going to do, but I tell them the first 6 parts that you make, put them in the bag put the label on them with all the documents and send them to, now it will be Donnie at Johnson Space Center in Houston. And he will inspect the parts, and then you can make more. Donnie, is that something that you would like, or what are you thinking?
I'm honestly not sure what the process is yet, Flo. That sounds good. I mean, I'm gonna be looking at them eventually,
Yeah,
but I do know Roy had been asking for sample sizes like that first before we, go full bore and make everything.
right. So what we really appreciate when the students actually check these parts while they're still on the machines for tolerances. So you check this as you go. Don't take it off the machine, but check what parts measurements you can while it's on the machine. Then when you have to flip it, then you can check again. You continually check for tolerances. That's the important thing. But usually you bag them, you put the label. That's a question on the test. Bag them, put a label on the bag, and send them to Houston. And once you send it to Houston, this is the evaluation sheet you'll get back. And I really like this evaluation sheet. It's kind of a summary of what we do. And here's the documentation that has to accompany all your parts. The drawing, that's what we've been looking at, okay? The drawing, the process sheet, it's called subassembly process sheet. This one says component process sheet, but that's 881. The dimensional inspection report, which is 829. And the other thing, which I didn't show you, because for some reason I just showed you a paper copy, is the, I call it the certificate of conformance. You can call it CERT, but it's the one with the lot number. These 4 documents you absolutely need to include. And if you do, you get complete. They'll check that off. And that's the easy part of this process. The next part is the part, deburred and no sharp edges. And he has satisfied minimum rework needed. And a lot of students get that minimum rework needed, but try to do it, take the time and do it as best you can. Like Donnie said, it takes a lot of finesse. Or complete rework needed. And I've had that sometimes too. Geometry is correct. That's your diameters and radius, dimensions and tolerance correct. Surface finished without scratches or marks on it and cleaned. You can see how important that control process is. It needs to be cleaned, surface finished, deburred, and the tolerances and the geometry is correct. So you will get marked on that. The labeling, you shouldn't have any problem because I put the part number and the description on the label, and the lot number has to be on the label now too. All those things, but I send you Mr. Hall, did I already send you that information? Did I send you the labels? Yeah, so you'll get that all complete. And then packaging, bagged and tagged. Each part has to be its own bag and tagged, and separated as best you can so the package is neat and the parts don't get damaged. And we send you UPS prepaid labels for mailing that out to us. And then there's always a spot for comments, and they usually say, great work. Thank you so much. So the hardest question on the test is this one right here. What are the 4 documents that have to accompany your part? The drawing, Form 881, Form 829, and the certificate of conformance. You can call it the CERT or the COC. That's the hardest question. But this is a good review of all the things that we just went over. Any questions on this sheet? You don't fill it out. Donnie and George and Carlos and all the people in Houston will fill this out for you. Okay, so now we only have 10 minutes left.
That's correct.
Okay, so do they have a copy of the test?
I do, I have a copy for each of them.
Okay, yeah, so that test is really short. It's mostly true or false. So do you want to give it to them now? Good.
Yep, we're handing it out.
While you remember it, it's good to take a test while you remember it. And Mr. Hall, you will get to choose who is your quality assurance person.
Say that again, please, Paul.
You will get to choose who gets the QC and the LM stamps.
Okay. Yeah, of course, we haven't decided that yet, but that time comes. I'll let you know.
I'm just checking. I went over all this. I think we're good.
Yeah. Okay, that's what I see. Push it.
Hey, Flo, I think I'm gonna go ahead and drop off then, since
Okay.
you're testing.
Yeah. Thank you so
Wonderful.
much for joining us.
Yes, thank you for inviting me. Thank you. Thank you, Mr. Hall. All right, talk to you later.
Okay, thanks, Donnie.
Which one do you know?
If you can.
I'm almost done.
Okay.
You want to go over this with them? Well,
Yeah, let's go over them. Is everyone done?
yeah, I'm just checking. Do you want the students to have the test? Or do you want-
They can grade their own test if you want, or just pass it out to anyone. They work for NASA now. This is, we have a high level of trust and great ethics. And we really appreciate your work. You need to make sure you brag about this. What if you get 100 on this test, which I hope you all do, you just pass the quality assurance. You could be a quality assurance person for NASA. And that, what we gave you is exactly what NASA uses for their quality assurance. I've had students go right from this class as quality assurance people and work at different aerospace and medical fields as the quality assurance person.
All right, well, I got about 5 minutes to go over.
Okay, so let's go over the questions. What measurement is on the above caliber depicting? Somebody stand up close to the computer and just yell me the answers.
0.313.
Correct. And if it was +5, stay up there. Stay up there the whole time. And if it's +5 thousandths of an inch, what would it be?
0.318.
Right. And -5 thousandths?
0.308.
Correct. How about true or false? You need to fill out 10 steps.
False.
Right. How many do you fill out?
5.
5. Only the month and day need to be written on the form?
False.
Right. What do you have to include?
Year 2.
Right. Sharp edges are allowed on the parts?
True.
Hey, that is actually true and false for your part only. Usually it's false, but you do have a sharp edge on your part. So I will take either answer, true or false, right? Because there's that one edge. The lot number is found on the drawing?
False.
Right. Where is it found?
COC.
COC. People can share their QC stamps with others,
False.
right? It's your signature. What are the 4 documents?
The drawing, Form 881, Form 829, and COC.
Absolutely.
Did we get that?
Each part should be placed in an individual bag with the proper labels on the bags.
True.
Keep the LM stamp in a secure location.
True.
If you cannot find the LM stamp assigned to you, it's okay to use someone else's,
False.
right? The DIA in the print dimension stands for diameter.
True.
All forms must be filled out with black or blue pen.
True.
True. And if a measurement is not within tolerance, highlight in yellow and do not stamp the row with the measurement on it. It's true. All right, put 100 if you got it all right. Put if you got one wrong, put negative -1 or whatever. And your teacher needs to collect them and save them for when Jean comes. How many of you got 100? Awesome. I could tell you were paying great attention. Thank you so much. You were really paying attention. I really appreciate that. So keep your notes because you probably don't need this information yet, but you need to review it when you are doing the inspection.
Handing the notes in, I'll be grading them and then handing them back.
So I missed what you said, Mr. Hall.
Handing in their notes, and then I'll be grading it, and I'll be handing the notes back to them.
Yeah, that's smart. Very good. I'm really impressed with your students there. They really are awesome. And now they should be bragging about that they just took a quality exam for NASA. Flight hardware. You are going to make flight hardware now. And that's really cool. So I want you to tell your parents, I want you to tell your friends, and I have a really good video that sometime when Jean comes, maybe we'll zoom in on. It's a 20-minute video about the HUNCH students. It's made by Edge Factor. Mr. Hall, have you ever heard of Edge Factor?
Familiar with it?
You are?
I am familiar with it. And actually, they did a lot of production here in Rochester, New York. So,
Oh, wow. So yeah, they made it in New Jersey. Jeremy Bout came to New Jersey with his team and made it about the HUNCH program one year.
really quick, can we have someone come up to the board and take a picture with you?
Oh my. Yeah, that's awesome.
Our fancy, got me going on Instagram. He does a great job with his social media. You should like to on Instagram.
Yeah. So actually take a lot of pictures and videos of the kids when they're working on the parts. That is so cool. Well, we're very fortunate to have you on the NASA HUNCH team, and congratulations all of you who did it. Good job.
Are you in, Brian?
And thank you, Brian, too, for helping with all that. I saw you passing out papers and keeping everyone on task there. What a team. That is awesome. I am sure if you have any questions about manufacturing, just ask, and we will make sure that you have questions answered and in quality assurance. So Gene is just learning to do this. He was an engineering teacher, but we have the experts at Johnson Space Center who answer any questions that you have, and you just have to ask, and we'll get you in contact with them.
Yeah, the only question I had was, if I bring it, I'll see from. The only question I had was, the other schools that, I think I might have sent this along to Gene. You know, did they have any special fixturing that they made or needed to make? And should we be aware of any issues that come up with past parts? And then I think when I sent the email, I said, or are you guys holding back as a test for us?
I have asked, so George Kessler, Donnie's new, but George Kessler's been doing this for a long time. And so I asked him, well, why don't you tell them the programming or suggest fixtures, you know, and stuff. He said, because they might come up with better ideas than we have. So, and I have not had anyone else do the fixture tube, the tube fixture that you're doing. I've had a lot of schools do this little fixture cap, but not the tube. But you should. Did they send you any parts that you could look at, like the tube fixture or the fixture cap?
They haven't, and I think you or Gene said that you were going to try to get the tube itself so we can take tests.
Yeah, so we need to ask George if he has some to send you, because that will help too. These parts, the drawings are old and they're not easy to read. And I know with the fixture cap, George had to make a video to help one of my teachers. I do the Western schools and the Northeast, and George had to make a video on this fixture cap part because it had some tricky, the part is tricky that even the way you flip it on the machine, it changes stuff on it. And, so I have a video on the fixture cap, but I do not have anything on the tube fixture. And but any question you have, you just ask about it and they can answer it if you seem to run in, but they won't give you ideas because they hope you come up with better ideas than they had. And we haven't made that many. Our main project has been the lockers. And so we haven't made that many handrails, but we are making a lot more this year. I have a lot more working on that.
That's awesome that you shared that with the students because they're going to be very proud of that.
Yeah. So, and Jean will bring you the locker. The kids get to sign the locker top because we can't sign the handrails, but we sign the locker top.
Yeah, he did bring it on his first visit to show up. So.
Yeah. Good, but we're all here to help. So that's our job, to make your job easier. But it looks like you have really good students which help, and you have Brian to help, which is a real plus because most of my manufacturing teachers don't have a good assistant like Brian is. So, and it makes a difference. I've had actually my Mr. R in OC BOCES or something like that. He has an assistant. Yeah, he's the only one. And I guess New York knows the right way to do it.
Joe and I have been at it a while, and we visited each other's classrooms a number of times. So, and we keep in touch. Actually, we were texting each other last night.
Yeah, yeah. Well, and so that's a reason why I really think it's good to make 6 parts and send it in, make sure it's right, and then you can go for as many as you want to make. I like that process. I tell my especially if they've made it for several years, I don't worry about it. But if this is the first year you're doing it, you should just make 6 and send them in.
Okay. Can you send me the purchase record form for tooling and fixturing?
So I couldn't hear you, Brian. You got to get right by the computer.
Can you email me the purchase requisition forms for tooling?
So did the students fill those forms out already?
Which one? Which form?
Talent authorization forms.
They did. Yes, you need to get those. We need to
Yeah.
get those.
Well, Jean will collect them. Jean will, and give them the test too. That's, give them the test and give them the forms. Thank you for doing that. Is your school on the map?
Yes, it is.
Okay.
All the purchase requisition forms for purchasing tooling.
So I'm not understanding exactly. Get right to the computer.
The purchase requisition form.
Oh, the purchase requisition forms. So did you get a supply request form?
No, I don't think we did.
Okay, so I'll send you one. So
Okay.
we have to purchase the stuff for you, and we buy it and we send it to you, but you fill out what a company and how you want to buy it.
Okay.
But we want you to use the best, tools so that everything stays within tolerance.
Right.
But I'll send you that.
I'm gonna have to sign on. We can get ready for the afternoon class and grab.
Yeah. Okay.
that.
Well, thank you all so much. We appreciate working with you.
And, oh, by the way, how far are you in Billings, Montana?
Yep.
Okay, so my sister lives in Anniston, I think it is. It's about an hour from Big Sky Mountain,
Yeah.
and so she's retiring up there in the next year. And,
Oh, wow.
so she's from South Carolina, and we were. I've been to Big Sky, Montana twice.
Oh, wow. Yeah. She lived in Ennis, E-N-I-S?
That is, yes. That's
Yeah.
great.
Yeah, that's actually, I've never been there, but I hear it's really beautiful there.
Yes. It looks-
Yeah. Well, good. Well, we need you at this school. Don't retire yet, Mr. Hall.
Well, I'll see you.
Okay. Thank you so much. Have a great day. Bye-bye. Bye-bye.